today we will demonstrate how to convert a PO box into a Wheatstone bridge and how to determine unknown resistance using this Wheatstone bridge method. Okay, so this is basically a PO box. So I will explain why it is called PO box. Actually, in earlier days, this box was used to determine the unknown resistance of telegraph wires or telegrams. So that's why it is called PO box. Okay, so we will determine unknown resistance using this PO box using this Wheatstone bridge method. So all of you know what is Wheatstone bridge. So Wheatstone bridge is nothing but this type of a bridge. Okay, so look carefully, there are some kind of resistance. This is P, Q, R, S. These are called ratio arms. Okay, when it is balance condition means this P by Q is equals to R by S. That means ratio of this resistance, okay, is equals to this. Then no current will flow through this galvanometer. Okay, so this is the galvanometer. So we will do the same circuit using this PO box. Okay, so this is the circuit diagram of this PO box. Okay, so look, there is some similarity. So this is actually point A. If you compare with this thing, yeah, so this is actually A point is here, B is here, C is here, okay, and D is this point. Okay, so look, so this is actually your P, resistance P up to this. Okay, here it is written, and from here to here it is Q, and from here all it is actually your R. Okay, and S will be your first. Let's close this thing. Okay, so this should be closed before starting the experiment. This should be closed. Okay. Okay, so this is your P, this is your Q, and whole this thing, this is your R, and another unknown resistance which will be determined. That thing will connect from C to D point, that is S. That is actually C, and that is D. So we will connect a resistance which value has to be determined from C to D point. Okay, so let's check. I have made the circuit, so let's check once. So let's start from A point. One more thing, so if you zoom carefully, there is some kind of this line, na? So that means this point and this point are connected. Similarly, there is some kind of lines. Okay, so these lines actually, this point and this point are connected. That means this point is B, this point is also B, this point is A. Okay, so this point is also A. Okay. So let's check the circuit diagram. So from A point, look carefully, from A point there is battery. So this is A and this is your battery. And another point, that is, it is connected to C point. Okay, so it is actually, this is C, this is A, this is B, this is C. Okay, and galvanometer is connected to B and D. So this is B, and this is also B. That I told that there is some kind of inside this box there is some kind of this line, na? So they are connected. So this B is from B. So one part of this galvanometer, this is galvanometer one part. Okay, and another part is, it will be connected with D. Okay, so this is D, and this resistance, unknown resistance, is connected with D and C terminal. So this is your D terminal. Okay, so D terminal, let's say this is my unknown resistance, and it is connected with C terminal. Okay, before starting the experiment, make sure that all points are very closely connected. So if there are some kind of loose connection, you can't find any null detection, or you can't find any balance condition. So I will explain what is balance condition means. Okay, so balance condition means, okay, so balance condition means, at balance condition, this is actually galvanometer. So when I close this keys, okay, so when I close this keys, that means it should not show any deflection, but now it shows some kind of deflection. Look this thing. Okay, that means it is unbalanced condition. Now it is unbalanced condition. Okay, so this part is up to that how to convert a PO box to a Wheatstone bridge. Okay, next thing we will start the experiment. That is, experiment is to determine unknown resistance using this Wheatstone bridge or using this PO box. Okay, so under balanced condition, what will happen? P by Q is equals to R by S. Okay, so if I simplify the equation, so look this, P by Q is R by S, S is my unknown resistance. So let's say S is equals to X. Okay, so if I simplify the equation, it will be Q by P into R. Okay, so I will put some resistance Q, P, okay, and I will try to find null deflection, that is no deflection in galvanometer, okay, for a particular value of R. So let's start the experiment. First choose your P is 10, Q is 10, okay, and the power supply it shows it is 2.9, any value it is okay. Okay, so try to choose in such a way so that it can show some kind of deflection. If you choose very low amount, so your deflection will be very little. So in that case, you can't determine null deflection. Okay, so let's check. So let's close the switch. Yeah, so look this thing. It shows deflection in left side. That means in this case, your Q is 10, P is 10. Okay, and R is now 0. Any resistance is not open, any key are not open, that means now resistance is 0. So in this case, it shows deflection in left side. Let's check here. There is this key shows infinity, INF, that means infinity. So if I open it, so look this thing, so it should shows in right side. Yeah, it is showing that the deflection is along right side. That means your unknown resistance is in between 0 and infinity. So we have to choose in such a way so that it will show 0 deflection. So let's check 10. Okay, so I will connect the keys. Yeah, so look at this. So it shows that deflection is along left side. Okay, so let's put another thing, 30, it is right side. Okay, when it was 10, it was along left side, and when it is 20, it was 30, not 20. Okay, so now it is 20. So when it is 20, it is along right side, but deflection is very high. Okay, so let's check another thing. Let's say it is 5. Okay, so 5, it shows it is left side. That means your unknown resistance is in between 5 and 10. Okay, so for 10, it is right. Yeah, for 10 it is right side, and for 5 it is left side. That means your unknown resistance is in between 5 and 10. So in between 5 and 10 you can choose many values. So let's say it is 7. 5 plus 2, 7. It is along left side. Okay, so let's choose another value, that is 5 plus 2 plus 2, that is 9. 9, it shows right side. Okay, nine is right side. Let's choose 8. 8 is along left side. 9 is right side, 8 is left side. That means your resistance is in between 8 and 9. But using this Q and P, you cannot choose other values. Since it is 8 and 9, in between 8 and 9, so you can't choose 8.5 or 8 point something. Okay, because there is no 0.5 or something else. So what we will do? Next thing, we will change this value. Okay, so first thing we have chosen Q is equals to 10, P is equals to 10, so ratio is 1, and your resistance is in between, it shows that is in between 8 to 9 ohm, that is R. Okay. So next we will change the ratio. We will choose Q is equals to 10 and P is equals to 100. That means now your ratio is 10 by 100, that means 0.1. So let's check again what is the unknown resistance in this condition. Your P is 100 and Q is 10. That means your ratio is 10 by 100, that means 0.1. So let's check again. Okay, so first close all this thing, all the values of R. Okay, so now R is 0. So let's check. It shows that it is along left side. Okay, now I will open infinity, same thing, infinity, it shows it is right. That means your unknown resistance is 0 and infinity. So let's check 100. Okay, I open 100. So let's see the deflection. It shows it is along right side deflection. Okay, so let's put another thing, 150 right side, but look at this, the deflection is much more compared to 100. That means your resistance is not 150, it will be less than 100. So less than 100, so let's choose 50 plus 20 plus 20, that means 50, 20, 20, 90. Okay, so look this deflection. So deflection is along left side. Okay, for 90 it is along left side, and for 100, so look at this, for 100, now it is 100, it is along right side. That means your resistance, unknown resistance, is in between 90 and 100. Okay, so 90 and 100 we can choose. So now it is 95, 50 plus 20 plus 20, 90 plus 95. So in 95, in which direction deflection? Deflection is along right side. Okay, now deflection is along right side. So let's say 95, 97, 97, 97, it is also right side, but deflection is more. So it will be not 95, it will be, let's say 92. Okay, 92. For 92 it shows along left side. For 90 it is along left side. Okay, for 92 it is also along left side. So let's say 91. Okay, for 91 deflection is, there may be some kind of loose connection, that's why it shows like that. Okay, so 90 for 95 it is right side. Okay, 95 it is right side, and 97 it is along left side. Okay, so your resistance is in between 95 and 97. So in this case, so in between 95 and 97, so let's say it is 96. So apart from 96 you can't choose, that is 96 point something, so you cannot choose. So it is your, now it is, that is your 9.6 ohm. So if you choose, if you want to check more precisely, okay, so 9 along, for these values of R, the galvanometer doesn't show null deflection. It is actually, it is not exactly at null deflection. So what we can choose? We can choose another value of Q and P. Okay, let's check. So let's check, that is Q is 10, P is 1000. Okay, so in this case your ratio will be 10 per 1000. That means it will be your 0.01. So in this case, let's check what is the value of R. Okay, so we will choose again. Okay, so next we will choose Q is 10 and P is 1000. So Q is 10 and P is 1000. Okay, so yeah, this one. Next we will check again what is the value of R for which your galvanometer shows null deflection. Okay, So let's check for now R is 0. Okay, R is 0, it shows deflection along left side. For infinity it should show along right side. Yeah, it is right side. So in between this 0 and 1000 your unknown resistance is there. So let's check 1000. Okay, this is 1000. Now I am closing this. So look, this thing almost I am around null deflection. So galvanometer shows little bit deflection. Okay, if you look carefully the pointer, it is little bit deflection. Okay, so let's check. Let's check for, it is 1000. Let's check for 3000. Okay, 1000, 3000. So now see this. It is not 3000. Okay, it is almost 1000. Okay, when I am choosing 1000, so it shows that almost we are around null deflection. Okay, so let's change again. So let's say it is not 1000, it is 1000, 500, 200, 200, that is 900. 900 it shows, look carefully, 900 shows deflection along left side. Okay, and your 1000 shows that it is along, yeah, it is along right side. That means your that resistance that will determine that null deflection, it is almost in between 900 and 1000. Okay, so in between 900 and 1000 we will check what value it will suggest. Let's say it is 950. So it is 500, 200, 200, 900, 950. So see the deflection, 950, it is along left side. Okay, it is along left side. So 950, now we will choose 970. 970 along which side? It is, yeah, almost we are at null deflection. Okay, 970. Let's check again, 990. Okay, 990. Yeah, we are exactly at null deflection. Okay, so this resistance R is 500, 200, 200. It is 900, 950, 970, 990. So your R is 990. Okay, so your unknown resistance is not 990 ohm. Okay, so unknown resistance we will determine from here. That is, your ratio is 0.01, that is 0.01 and 990. That means your unknown resistance is 9.9 ohm. Okay, so using this Wheatstone bridge method and using this PO box, we can determine what is the unknown resistance. Look there, their resistance is 10 ohm. Okay, it is written 10 ohm. That means, and I am determining that unknown resistance is 9.9 ohm. That means our experiment is very much fruitful. Okay, so using this experiment, we what is the outcomes? Outcomes is, first we try to convert this PO box to a Wheatstone bridge. Okay, and using this Wheatstone bridge with the null deflection condition, we can determine what is the unknown resistance. Okay, so this is the one of the part of this experiment. In another part, in next part, we will determine, that is, what is the resistance combination. Okay, so we will determine what is the resistance combination in using series combination. What is the resistance, and we will compare it with the theoretical value. Okay, so in next part we will show it. Okay.